Electric dipole. Electric dipole is the separation of positive and negative charges. The simplest example is a pair of electric charges of equal magnitude but opposite signs, separated by usually a small distance, as shown in the picture here. In the simplest case of 2-point charges, one with plus q and one with minus q, the electric dipole moment is given by P equals qd, where q is the charge on one of the two contributing charges, and d is the displacement vector pointing from the negative charge to the positive charge. The dipole moment vector p points from the negative charge to the positive charge. In an idealization of this two-charge system is the electric point dipole, consisting of two infinite charges only infinitesimally separated, but with a finite dipole moment equals to qd. The electric field from a dipole moment is calculated and is given by E equals 1 over 4 pi epsilon naught p over x squared plus d over 2 squared 3/2. So this looks like a really complicated problem, but it really isn't, and we're going to solve that on the board. Also, electric field from a dipole is given by E equals 1 over 4 pi epsilon naught p over x cubed. Again, these all follow the same pattern, and we are going to solve them on the board right now. So let's solve the problem of electric field from a dipole. Okay? So a dipole is plus and minus charge, right? So we have a plus charge here, we have a minus charge here, and we know that the dipole moment is going to point from the negative to the positive charge, right? So this is the dipole moment. If I want to find the electric field at point P away from the dipole moment, and the distance between these two dipole moments is d, so then this is going to be d over 2 and d over 2, right? So this is going to affect, oops, sorry, wrong side, and this is going to affect, right? This is a positive charge, and this is, I think I'm going to point it this way, negative charge, okay? Because E field will go towards. So I'm going to call this E minus and E plus. Okay, these are the two fields that we're going to have. So I'm going to call also this theta and this theta, this x, just to make things simple. So my coordinates will look like x axis. So it'll point towards the x. And my z-axis, my x-axis is going to be into the page, and this is going to be my z-axis. So think about it in the way that this is x, y, and z. So that's what my picture will look like. So x goes this way, y goes into the paper, and z goes up. Okay? So I'm choosing the electric field due to the positive charge be E plus and the electric field due to the negative charge be E minus, okay? However, the magnitudes of both of those E's, magnitudes, will be exactly the same. 1 over 4 pi epsilon naught Q over R squared. So that's one thing I absolutely know, okay? So this means my E total will be E plus plus E minus, okay? And this is, again, also for plus and also for minus. So they're going to be exactly the same. If I call this R will be equals to x squared plus d over 2 squared, right? Square root. Pythagorean theorem, that's what it's going to be. So this implies that this actually will become E plus or minus magnitude will now be 1 over 4 pi epsilon naught Q over x squared plus d over 2 squared. Okay, that's one thing I know. So Now let's try to figure out what actually is going on. So for the x component, e plus sine theta and e minus sine theta will equal 0. So the x component goes away. So my e total will only have z component, which is going to be e plus cosine theta plus e minus cosine theta, which will give me 2e magnitude cosine theta. Now I know that e is equals to that, and cosine theta, if I was to calculate what cosine theta would be, cosine theta will be equals to base over r. And if this is r and this is the base, it will be d over 2 divided by r. Yes? And r I know is x squared plus d squared. So cosine theta will be equals to d over 2 divided by x squared plus d over 2 squared square root. I can plug this value in here, and I can plug that value in there to give me, so I'm going to start over here. So E total will become equals to 1 over 4 pi epsilon naught q over x squared plus d over 2 squared times cosine of theta, which is d over 2 divided by x squared plus d over 2 squared square root. Okay? Which if I simplify, I will get 1 over 4 pi epsilon naught p over x squared plus d over 2 squared 3 over 2 E total. So when we looked at this, so remember when we looked at this over there on the screen, we thought, oh my god, this is really complicated. It really isn't. It kind of just follows through. Okay, now for step 2. For points very, very far away as compared to D, so if you were to take this point P and move it really, really far away, say at this point P here now, what will happen? So this will be like a limiting case. In this case, you are going to use, for the limiting case, use binomial expansion, okay? Which means 1 over x to the power n will be 1 plus nx plus so on and so forth, right? If you were to apply that to this particular problem, your E total will reduce down to 1 over 4 pi epsilon naught p over x cubed 1 plus d over 2x minus 3 over 2. Okay? And plug that into here for binomial expansion. You're going to get 1 over 4 pi epsilon naught p over x cubed, 1 minus 3 over 2 d over 2x. Okay? Now in the limiting case, what was the limiting case? When x is much, much bigger than d. When x is much, much bigger than d, this number becomes really, really tiny. And so what you're left with is 1 over 4 pi epsilon naught p over x cubed.